Hello my dear students, I welcome you all. Today we are going to start a new lesson for class 10th students, that is chapter 9, some applications of trigonometry. In this lesson you will understand some applications of trigonometry. Applications of trigonometry means how to find the height, distance, etc. for some vertical objects. To use the applications of trigonometry, we have to understand few terms and concepts. The first one is angle of elevation. The angle of elevation has a role whenever you observe an object from a lower level to higher level. That means, in figure, this is the horizontal ground level. So, this line represents a horizontal ground level. Here, AB is some vertical object such as tower, pole, building, etc. And from a distance from the foot of the tower, that is BC is the distance from the foot of the tower, we have a point C which is marked in the ground level itself. If a person observes the top of this vertical object such as tower, pole, etc., he will look at the top of the tower making some angle with the horizontal ground level. Just imagine a line which goes from the ground level to the top of the tower, which is the line of sight. Here AC is the line of sight. The line of sight always makes an angle with the horizontal ground level, which is marked theta. Here theta is the angle of elevation. So remember students, if angle of elevation is given, it means that the object is observed from the ground level or a lower level to a higher level or a higher point. In figure AB represents the vertical object, BC is the distance of the point of observation from the foot of the vertical object, AC is the line of sight. So here theta is the angle of elevation. Another situation is when an object which is in the horizontal ground level, that is, suppose C is the object which is on the ground level and is observed from a point which is above the ground level, that is maybe from the top of a building, top of a tower, top of a pole, etc. In that case, the line of sight will be from A to C, and here if you draw a line parallel to the horizontal ground level through the point A, we can see an angle theta which is formed between the line of sight and the parallel line to the horizontal ground level. The angle formed between the line parallel to the horizontal ground level and the line of sight is called the angle of depression. Here, this is the angle of depression. Of course, this angle is not inside the triangle, but by using the property of alternate interior angles, if this is theta, this angle is also theta. So whether it is a case of angle of elevation or angle of depression, you can see that always a right angled triangle is formed. In the case of angle of elevation, the object is observed from a lower point to a higher point. So the angle of elevation will be within the right angled triangle formed. But in the case of angle of depression, the object is observed from a higher point to a lower point. So the angle of elevation is formed outside the triangle formed, that is the right angular triangle formed, but can be brought into the right angular triangle by the property of alternate interior angles. My dear students, according to the 10th syllabus, we will have to solve questions involving one right angled triangle or two right angled triangles. Whenever you get a question, it is very important to understand the situation. If the situation is familiar for you, it will be easy for you to present the situation in the form of a right angled triangle by representing the vertical object as the perpendicular, distance as the base, and the hypotenuse may be the line of sight. So we are going to the exercise. In exercise there are several questions which are very familiar for us. The situations are very familiar. We will draw the right angled triangle and we will use a suitable trigonometric ratio to solve the question. So let us start the exercise. The first question of the exercise is: a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. The situation is very familiar for us. Here a circus artist is climbing to the top of a pole through a rope. Here we have to represent first the horizontal ground level. And there is a vertical pole, so I use AB to represent the vertical pole. Here A is the top of the pole and B is the foot of the pole. A 20-meter long rope is tied from the top of the pole to a point on the ground very tightly. That means here AC represents the tightly tied 20-meter long rope. So according to the question, here AB represents the height of the vertical pole in which A is the top and B is the foot. C is the point to which the 20-meter long rope is tied tightly from the top of the pole. So here AC is equal to 20 meter, that is the length of the rope, and according to question, this rope makes an angle 30 degree with the horizontal level. So here angle 1 is 30 degree, which is the angle of elevation. So first of all, we will write a small description about the figure. In figure, AB is the vertical pole whose height is to be calculated. AC is the length of rope, that is 20 meter. Angle 1 is the angle between the 20-meter long rope and the horizontal down level. According to question, it is 30 degree. This is angle of elevation. So we have a right angle triangle here with the one acute angle 30 degree and hypotenuse 20 meter. We have to find the height of the pole. So with respect to the position of angle 30, AB is perpendicular and AC is hypotenuse. which is the trigonometric ratio formed between perpendicular and hypotenuse? Sine ratio. So here we will use sine ratio to form a relation between the perpendicular AB and hypotenuse AC with respect to the position of the acute angle 30 degree. Now, in right triangle ABC, sine 30 degree is equal to perpendicular AB by hypotenuse AC. You know what is the value of sine 30? That is 1 by 2. 1 by 2 is equal to AB by AC is 20. On cross multiplying, you know that you get 2 into AB is equal to 1 into 20. Therefore, AB is equal to 20 by 2, which is 10. AB is equal to 10 means that is height of the pole. That is height of the pole is equal to 10 meter. Now look at question number 2. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. Here the situation is different. A tree is broken due to the wind, but the broken part is not completely detached from the remaining part. The broken part bent and the top of the tree touches the ground, making an angle of 30 degree with the ground. We have to find the height of the broken part. So first of all, we have to show the horizontal ground level. This is horizontal ground level, and we have the tree is divided into two parts. Here AB represents the remaining part and it is broken at a point B, and BC represents the broken part. Here AB represents the remaining part of the tree and BC represents the broken part of the tree. According to the question, the top of the tree, that is the broken part, touches the ground, making an angle of 30 degree, and the distance from the point C, that is the point where the top of the tree touches the ground, to the foot of the tree is 8 meter. Now in figure, according to the question, AB is the remaining part of the tree, BC is the broken part of the tree. AC is the distance between the foot of the tree and to the point where the top of the tree touches the ground. The angle between the horizontal ground level and the broken part is 30 degree. Let it be angle 1. First of all, let us give a small description about the figure. In figure, according to question, AB is a remaining part, BC is broken part, AC is the distance, which is 8 meter. Angle 1 is the angle of elevation, that is 30 degree. What is our question? We have to find the height of the tree. Height of the tree means it is the sum of the remaining part AB and the broken part BC. So we have to find AB and BC from this right angle triangle using the suitable trigonometric ratio with respect to the acute angle 30 and the side AC. Now, in right angle triangle, first of all I use tan ratio because with respect to the position of angle 30 degree, AB is perpendicular and AC is a base. So I take tan 30 is equal to perpendicular AB by base AC. The value of tan 30 is 1 by root 3 and AB is the remaining part of the tree by AC is 8. Cross multiplying you will get 8 into 1 8, AB into root 3. AB into root 3 is equal to 8. Therefore, AB is equal to 8 divided by root 3. This is the height of the remaining part. Now we want BC. With respect to the position of angle 30, BC is the hypotenuse and AC is the base. So we will use Cos ratio. Now, in right triangle ABC, cos 30 is equal to base AC by hypotenuse BC. Cos 30 is root 3 by 2 is equal to AC is the base, that is 8 divided by BC is the hypotenuse. Cross multiplying we get BC is equal to 8 into 2 16 divided by root 3 meter. So we have a remaining part AB is equal to 8 by root 3 and the broken part BC is equal to 16 by root 3. So here total height of tree is equal to AB plus BC, which is 8 by root 3 plus 16 by root 3, having same denominators 8 plus 16 24 by root 3. Denominator is irrational, that's equal to 24 into root 3 by root 3 into root 3. Multiplying numerator and denominator by root 3, we get 24 root 3 by root 3 into root 3, 3 and 24 will be cancelled, that is equal to 8 root 3 meter. So the total height of the tree is 8 root 3 meter. If we substitute the value of root 3, the value of root 3 is 1.732. We get 8 into 2 16, 8 into 3 24 plus 1 25, 8 into 7 56 plus 2 58, 8 into 1 8 plus 5 13, 13.856 meter. In the decimal form, the height of the tree is 13.856 meter. Remember students, in the examination, if the value of root 3 is given along with the question, then only you will have to multiply 8 with the value of root 3. Otherwise, if you leave the answer in the irrational form, that is 8 root 3 meter, then also you will get the full mark. But if possible, if you have time, try to substitute the value of root 3 and complete the calculations. That is all for today. We will meet in the next class with a few more questions from the applications of trigonometry. That is the questions based on heights and distances. Till then, take care. Goodbye.